Trig ratios show up a lot on the SAT math, and they aren't given on your reference sheet, so you have to know them. The acronym commonly used to remember them is SOHCAHTOA. SO reminds us that the sine of an interior angle of a right triangle equals the opposite side length divided by the length of the hypotenuse. CA reminds us that the cosine of an angle equals the adjacent side length divided by the length of the hypotenuse. And TOA reminds us that the tangent of an angle equals the ratio of the opposite and adjacent side lengths. Now, it's very important to remember that these ratios are only true for interior angles of right triangles. It's also important to remember that the opposite and adjacent side lengths are always relative to the position of a particular interior angle. For example, if I consider the trig ratios of this other angle, alpha, then the opposite side length is now 3 and the adjacent side length is now 4, which results in different values for all three of the trig ratios. Now here's an example of how this concept could show up on the SAT math. Here we have a triangle JKL where J is a right angle and the cosine of K is 24 over 51. Let's draw it. We are given that the cosine of K is 24 over 51, and we know that the cosine of an angle in a right triangle is the ratio of the adjacent and the hypotenuse side lengths. So we can label the side adjacent to K as 24 and the hypotenuse as 51. But keep in mind that this is just an example of a triangle that has this ratio. We are actually unable to find the exact side lengths of triangle JKL with the information we are given. But we can find the value of the cosine of L, which we know is the length of the adjacent side to L divided by the length of the hypotenuse. In our triangle here, the length of the hypotenuse is 51, but we don't know the length of the side adjacent to L. So let's call it X. Since we know two side lengths of a right triangle and want to find the third, we can use Pythagorean theorem. Pythagorean theorem tells us that x squared plus 24 squared equals 51 squared. So we can subtract and then take the square root of both sides to get x equals the square root of 51 squared minus 24 squared, which we can simplify by plugging it into Desmos and getting 45. Therefore, the missing side length of our triangle here is 45, and the cosine of L is 45 over 51, which is our final answer.